Hi, my name is Bonnie Acosta, and I'm doing my critical assignment video for Geoscience 151, Professor Dahl. I decided to do the experiment on running water and groundwater, which I found very interesting because I really didn't know where our water was coming from. When you hear well water, I didn't really know what that meant. So, the purpose of our experiment today is to determine the permeability and the porosity of certain materials, such as sand, clay, and I believe we're using pea gravel. I gathered all the materials needed for my experiment. I gathered the plastic cups, the styrofoam cups, okay, so to get started, I was asked to put the pea gravel in the plastic beaker and fill it to 100 mils. Sure, a little above. Remove just a bit. Okay, so 100 mils. Okay, now we're going to do this with the others also. In cup number 1, I'm putting the pea gravel. Okay, this is sand, 100 mils. And in cup number 2, I'm putting the sand. Next is the clay. And I really, ooh, it's so soft. Let's do that. Oh, good job. Okay, 100 mils. Okay. Now the directions say, rinse the plastic cups, which I did. Rinse and dry the beaker. Repeat steps, and in clay, which I did. Okay. So I'm going to observe each of the samples and formulate a hypothesis. Well, since I've already done this assignment, my hypothesis was, I think that the pea gravel was not going to be porous enough to actually hold water. That was my hypothesis for that one. And I thought the sand would also I thought the sand would not hold water. However, in my hypothesis, I knew that the clay would not only hold the water, but it would soak it in and turn hard as a rock. So, next it says to record my hypothesis in panel 1. which I have done. Now, record the volume of each dry sample in data. Okay. So, I'm going to do that. I have copied the data, and I will be writing all of my things in my data. So, I know that the sample volume is 100 for each one, 100 mils. So I already have that written down. Now the next step is, okay, so now it says to add 25 mils to the cylinder. Okay. Now it says to add 25 mils of water to the cylinder. Since I like to control the water, I used a squeeze bottle for it. Okay. Here's the 25 mil. Tell me to pour it over the gravel. Here I am. Now it says that I might need more. Clearly I do. Because we're supposed to at least submerge the rocks. So I've added 25. 50. So 50 mils is just covering the surface. I think I'll do just a little more. Maybe another 10 mils. So 60 altogether. Now 60 is covering the pea gravel in cup number 1 completely. Now I was told to do the same to the sand. So we're going to start with cup number 2, the sand, and 25 mils of water. 5 mils. As you can see, 25 mils. Ooh, that's soaked in. But it's definitely going to need more. Because as it says, we need to submerge the sand. So we'll try another 25. Okay, another 25. I am really trying hard here to stir this clay. In my ceramics class, I used to have this, but I never had to record its porosity or permeability, which this has none, by the way, so far. Okay, 100 mils. And I think that I will add a couple more. How about another 15? So 115 mils, and that is completely saturated. I stirred, and it really won't let me stir anymore. I'm going to try some more. Okay, so I'm going to record the volume added to our data sheet, which I'm doing. So, the gravel, we added 100 mils. Okay? And to the sand, we added, to the gravel was 50 mils. I'm so sorry, 50 mils. recording into the data. So the gravel, we did 50 mils. The sand, we did 115 mils. And the clay, we did cheesecloth on top of the cups, which I am doing here, here. Okay. Now we don't want any of this stuff to escape, except for into our cups, correct? Correct. Okay. Clay is on tight and great. Okay. The gravel. Now the gravel. Oopsie. Okay. 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 Cool. And okay, all nice and snug here. Now the sand is kind of heavy. I want to make sure that this one is on very well. Now it says to invert. Next step is to invert the cups. So first we're going to do the gravel. Okay. Then I'm going to do the sand. And the reason I'm doing it this way is because I want all the water to actually come out of the cup the correct way. Okay. And now the clay. To me, inverted means all the way upside down. And then it says to wait 1 hour. So in 1 hour, I will be back to record more data. Okay, so it's been exactly 1 hour. And I have my sheet to record. Okay, so the directions say that I need to pour the liquid that's left in the cup, in the styrofoam cup, into the beaker. So, we'll start with the clay. Oh, that looks... Oh, I'm so excited this time. It actually has some in there. Not much. But look at that. It has 10, 13. 13 mils this time. Yes. for that back. Okay. That this says. Oh my goodness. There's the 25. 25. Write that down so I don't forget. And, oh, another 25. Wow. So, this released all 50 mils. I'm very shocked that it twice 50 mils. Wow. Mils. Make sure that all the water is out of this beaker. I don't want to any faucets. Okay. Now we have the sand. As you can see, it's kind of wet. Oh, there's sand in there. Sand seeped through. So, let's find out. Mils, sand, head. There's 25. 25. And maybe another ounce, so maybe 26 mils. That's great. So the first thing that we need to do is find the porosity according to this. And what the formula is the porosity equals the added water volume, which is, for the gravel, we added 50 mils. Okay? Then we're going to divide it by the sample volume. Okay? Which is 0.5. It says 0.5. And then it says to times it by 100. 50%. Porosity. Okay. And I will do the same for the others. So we had 60 mils divided by the 100. The sand. Okay. Equals 0.06 times 100. 60. Okay. 60%. Then we have 115 mils for the clay. Okay, we're going to divide that by 100 mils. It's 1.15. Then we're going to say times 100 is 115. Time to record the data of the permeability. Okay, and how to do that is the released water volume divided by the added water volume times 100%. Okay. So, for the gravel, we have the released water of 50 mils. Okay. All right. Times 50 mils. And divided by the added water. Okay. Divided by the added water. Okay. And this says times 100%. And I got 1. Okay, then we'll go on to the next one. The added water is 60 mils by 68% times 100. Thousand? That can't be right. Sorry, when it comes to math, I get scared. I don't have to do math very well. 60 mils times 5. All the water from our sand and gravel. Now we're going to do the permeability. So, formula for the permeability is the gravel was permeability, the released water volume divided by the added water volume times 100%. So, gravel is the released water, which was 50 mils, divided by the added water, 50 mils, times 100%. I get 1. Now, this is now on to sand, which is the released water of 26 mils, divided by the added water, which was 60 mils. 60 mils is 0.43 times 100% equals 0.189. 0.188. Okay? And now we have the released water for the clay, 13 mils, divided by the added water of 115 mils equals 0.304 times 100%, which is 0.113. Okay, and now that we have entered all of our data into the little data sheet, we are now finished with our research. Thank you so much. Have a great night.